Okay, let's talk about subset. So you are given an integer array nums, and element inside nums array are unique, right? So you just return a possible subset, all possible subsets, and the solution set must not contain duplicate subset. So you should give 1, 2, 3 and an empty 1, 2 and 1, 2, 3, 1, 3, 1, 2, 3, 1, 2, 3. Okay, they are not duplicated, but they are all possible subset. So let's just jump to code, and I have a list of integer that store the answer, and I do have a temporary list which is stored in my temporary element, and if I add into it, I just add into list of lists. And I also have my starting index when I do the backtrack. So I'm not talking about base case. Base case is pretty simple. So what happened on the backtrack solution? Did you see the empty spot? And since there's nothing inside temp list of integer from a temp list, right? You just add. How do you add? Just add the list dot add temp, right? Okay, this doesn't work. Why? Because the type doesn't match. So you need a array list and temp. Okay, that's the idea. So how do you do it? So you're starting from the index star, right? So start and then less than length and then increment, right? They should not be duplicated, so you cannot have because it's unique, right? So you cannot repeat yourself, right? So when you do a recursion, backtrack stuff, you need to increase 1 on your I position, and that's the idea. So when you do the next backtrack solution, you will avoid the duplicate. So how do you actually add? So you add the value into a temp list, and you also need to remove, right? So how do you remove? Remove is the index problem, so you need to be a size -1. So that would be remove the last element. Okay, let's just run it, and then we'll talk about time and space complexity, because time and space is really hard to explain. So I pull out something. It's pretty simple. So let's talk about, let's look at the diagram. So this guy, so give credit to this guy before drawing. So empty element, and then you have 1 generate 2, 1, 2 generate 3, and then you can generate 3 on your right side, and also 2, and then 3, and that's all possible way, right? And they are all unique. So let's talk about time and space. Okay. So you can code it, you can read it. The recursion function is called 2 to the n time, and because we have two choices at each iteration in nums array. Either we include nums I in the current set, or we exclude nums I, right? So that would be n for every single level. So it's 2 to n, and you need to call how many times? N over 2 times, right? Because it's half of the tree, right? So that would be, the final answer would be this: n times 2 to n for the time, n times 2 to n for the space. And if you want to read more explanation, you can just visit this discussion, and then peace.